Hello, I'm Charlie Riggins with Pi Barker. Industrial growth is not just about building more factories or buying more equipment. It is about making smarter decisions about where we invest our resources. Where do we build manufacturing capacity? Where does energy investment deliver the greatest return? And how can automation help manufacturers produce more when skilled labor remains difficult to find? Today, we'll look at a major expansion of solar manufacturing in Georgia, a debate over where carbon reduction investments can have the greatest impact, and how CNC machine tending is helping manufacturers increase productivity with automation. Let's get started. A recent Latitude Media article looks at a major expansion in Georgia's solar manufacturing industry. Q-Cells has started producing solar cells at its factory in Cartersville, Georgia. The milestone moves the company closer to creating a fully domestic solar supply chain. The Cartersville facility is expected to become the only factory in the United States producing the major components of a solar panel, including ingots, wafers, cells, and finished modules, under one roof. Production is still ramping up. By the end of 2026, the plant is expected to reach 3.3 gigawatts of solar cell capacity. Together, Q-Cells facilities in Cartersville and Dalton can produce 8.6 gigawatts of finished solar panels each year. That is equal to roughly 1/5 of the solar capacity installed across the United States last year. The expansion is important because the U.S. has increased its ability to manufacture finished solar panels, but it still has supply chain gaps in areas such as solar cells and wafers. Those gaps can create risks when manufacturers depend heavily on imported components. Recent customs delays, trade restrictions, and changing tariff policies have shown how quickly overseas supply problems can affect domestic production. Manufacturing more solar components in Georgia gives developers greater supply certainty and may help qualifying projects receive federal incentives for using American-made materials. The Cartersville factory represents an initial investment of about $2.5 billion. Federal manufacturing tax credits are expected to offset part of that cost and have played an important role in encouraging companies to build clean energy factories in the United States. However, the article also points to continued uncertainty. Solar manufacturers are still dealing with changing tax rules, import competition, permitting delays, and questions about future demand. Georgia is becoming an important center for domestic solar manufacturing. Expanding production beyond finished panels and into cells, wafers, and other components can strengthen the U.S. supply chain, reduce exposure to overseas disruptions, and create new opportunities for manufacturers and suppliers across the Southeast. Georgia's solar expansion is one example of how investment decisions can reshape an industrial supply chain. But investment decisions matter on the energy side as well. As companies, utilities, and governments look for ways to reduce emissions, they also have to decide which technologies deliver the greatest benefit for the money being spent. That brings us to our second story. Another Latitude Media commentary looks at the growing debate over direct air capture. Direct air capture, often called DAC, uses large industrial systems to remove carbon dioxide directly from the atmosphere. Supporters see it as a potential tool for addressing emissions that are difficult to eliminate. But the article argues that the most important question is not simply whether a direct air capture plant removes more carbon than it produces. The better question is this: where can each dollar deliver the greatest climate and public health benefit? Researchers compared investments in direct air capture with investments in utility-scale wind and solar projects across the United States. Under current assumptions about cost and energy use, wind and solar delivered greater benefits in nearly every region. One major reason is electricity demand. Direct air capture requires significant power to move large volumes of air and separate a relatively small amount of carbon dioxide. When that electricity comes partly from fossil fuel power plants, the process can create additional emissions and air pollution. Wind and solar projects work differently. They can replace fossil fuel generation directly, reducing both carbon emissions and pollutants that affect communities near power plants. The local electric grid also matters. Direct air capture performs better in regions with cleaner electricity. In areas that still depend heavily on coal or natural gas, its indirect emissions and health effects can reduce its overall value. The article does not argue that direct air capture should be abandoned. The technology may eventually play an important role by removing carbon already accumulated in the atmosphere. That could become especially valuable after power generation and other major industries have reduced most of their ongoing emissions. Continued research may therefore be worthwhile. But the authors argue that large-scale deployment should not come at the expense of cleaner electricity and direct emissions reductions today. Carbon removal technology should be judged by its full system impact. That includes energy use, local grid conditions, air pollution, public health, cost, and the alternatives available. That debate comes down to getting the greatest result from limited resources. And manufacturers are dealing with a very similar question inside their own plants. Instead of asking where each energy dollar delivers the greatest benefit, plant managers are asking how they can get more production from the people, machines, and hours they already have. That is where automation is becoming increasingly important. Our final story looks at one area where that change is happening quickly: CNC machine tending. A recent American Machinist article looks at how CNC machine tending is helping manufacturers increase productivity while dealing with ongoing skilled labor shortages. For many machine shops, automation is no longer limited to large companies running high-volume production. New collaborative robots, modular work cells, and easier programming tools are making machine tending more practical for small and mid-sized operations. Collaborative robots, also known as cobots, can load and unload CNC machines without the complex guarding and programming traditionally associated with industrial robots. Many systems use graphical controls or allow employees to guide the robot through its movements by hand. This means existing plant personnel can often learn to operate the system without becoming automation specialists. Artificial intelligence is also improving machine tending reliability. AI-powered vision systems can recognize a part's position, confirm that it has been loaded correctly, and identify defects before machining begins. These systems can also adjust for small differences in part placement, reducing interruptions and the need for operator assistance. Machine tending is also expanding beyond basic loading and unloading. A robot may remove a finished part, clean it, move it through inspection or deburring, apply a traceability mark, and place it into a tray or package. Combining these tasks into one automated cell can improve throughput and reduce errors caused by repeated manual handling. Another growing opportunity is lights-out machining. With reliable robots, tool monitoring, and remote supervision, shops can continue producing parts overnight or during weekends without adding another staffed shift. Connectivity also gives managers real-time information about cycle times, downtime, equipment utilization, and overall performance. The article emphasizes that flexibility is becoming just as important as speed. Modular cells, quick change grippers, and movable cobots allow one automation system to support several machines or different production runs. Machine tending is not simply about replacing skilled workers. It allows experienced machinists to spend less time on repetitive loading and more time on setup, programming, quality control, and process improvement. Across all three stories, one theme stands out. Industrial competitiveness increasingly depends on using resources more effectively. Georgia's solar expansion shows how domestic manufacturing capacity can strengthen supply chains and reduce dependence on overseas components. The debate over direct air capture shows why new technology has to be evaluated as part of a larger system, including energy use, cost, emissions, and the alternatives available. And CNC machine tending shows how manufacturers can use automation to increase machine utilization while allowing skilled employees to focus on higher value work. For plant managers, engineers, maintenance teams, and procurement professionals, the lesson is not that every new technology deserves an investment. It is that every investment should solve a real problem. Does it strengthen the supply chain? Does it lower operating costs? Does it improve productivity? Does it make better use of skilled labor? And does it make the operation more reliable and competitive over the long run? Those are the questions worth asking as manufacturing continues to change across Georgia, Florida, and the rest of the Southeast. I'm Charlie Riggins with Pi Barker, and thanks for spending a few minutes with me. For more industrial news, practical insights, and support for pumps, compressors, blowers, and vacuum systems across Georgia and Florida, visit piebarker.com. Until next time, stay safe, stay productive, and keep those systems running.